Hello and welcome to part 9 of my tree generation series. And in this video I'm gonna show how we can make this little tree here trace around things. So to begin with, I want to add a sphere to my scene. Put it like here, and I'm also gonna drag in a cylinder, which I'm gonna turn this way and do something like this, just so I have something to test with. I think I'm gonna move this a little bit to the side so it's not so much in the dark. Okay. Before I do anything, I want to take off this randomization stuff here, so it doesn't do all that stuff constantly. And I think I'm also gonna set this to a very high number, like 100, and say I want to make like 30. Whoa, that was long. Okay, anyway. Right. So the trick here with the wrapping logic that I implemented, and I'm not really sure how Ryan Brooks did it in his, but I guess it's kind of similar, is that I trace forward. So instead of just moving forward, then I do a trace forward, and if I hit something, then I will adjust it to that surface. So that means that I also need to keep track of if I am in contact with something and where I want this to if I want it to wrap around something. And I'm not going to cover that in this video because it's I'm just going to be covering the basics of this tracing algorithm. So we have this part here where we add something to the local to the relative location. I'm going to take that out for a moment, and I'm going to keep this add segment stuff right here. I'm going to move that all the way out here because I need a little space. And then I'm going to say, call this add randomization. Is that how it's spelled? I'm not really sure. So this is just the randomization. So we're gonna make a trace. And we've been doing everything in relative or local space, but for the traces we need to do things in world space. And luckily when we change our turtle in local space, the coordinates also update in world space. That kind of makes sense, but I think it's pretty nice in a way. So what I want to do here is to get my turtles forward vector, and I'm gonna multiply that by the length, my local length here, just as I did before actually, and that gives me the distance forward. So on top of that I also need my world location, where in space it is, and then I need to do a line trace by channel, and this is going to be my start, and my end is going to be the same start point plus the forward location. That's going to be here. We can hook this part up here. Okay, so this part here is really the trace forward part, and maybe a little bit more, because we need to do something about this. So we want to make a branch, and depending on if we hit or not, we want to do two things. So break the hit result, that thing we can do. So if we hit something, then we want to adjust our location to be on that hit location, but the impact point, it's giving us that exact point, and we don't want to constantly make a hit next time again. So what I'm going to do in order to get this position is I'm gonna take the impact point and I'm gonna add the impact normal. The impact normal is, if you don't know, I hope you do, but the impact normal is the vector pointing outwards from the surface. So let me just quickly make a little drawing. It's kind of basic, but anyway, it's gonna make this perfectly clear. So if I have this circle here, and we have the tree growing in this direction, and here it doesn't hit, but next time it says, okay, this is the point I want to be at. So I'm going to set this point to be kind of in the middle. This is a bad example. Let me do another one. We have a circle, we have a point, and it moves forward. Okay. And it's supposed to go here, but it can't go through, so it's going to put that point here. And then it's going to take the normal. It's a vector pointing perpendicular to the tangent of that surface. So here's a 90-degree angle. And I'm going to take this forward point, so it's going to basically put it a little bit outside. So it's not going to be spot on, but it's just going to be outside. Shitty explanation, sorry about that. That probably didn't help. Anyway, so we also need to adjust the rotation. I actually need to draw something more, I'm afraid. Anyway, maybe it makes sense. So in order to get the rotation, because we need to deflect it off the surface so it doesn't continue in that same direction. Yeah, I'm sorry, I need to draw something again. So we have this here, and it comes in this way, and we basically want it to go that way afterwards. And the way we're going to do this is to use the information that we get from the hit. So the hit normal, this is the normal. It's giving us the up vector of this. And the turtle itself has a right vector and an up vector. We can't really use the up vector for anything, but we can use the right vector because it has a direction itself. So we can actually, the math of this is actually, behind this is actually to have two, if you have two vectors here, so this is the right, and this is this is the up. And if you cross product these two vectors, then you're going to get this one. So that's the cross product between the up and right is going to give you this. But luckily we also have a few functions for that, for generating that. And so we don't have to do all the math ourselves. We can actually just construct a rotator based on two vectors here. So we know the up vector is going to be the c. This is going to be the c vector direction, and the y is going to be the right vector. So that's going to give us this unknown x, and we don't really need that in order to construct a rotator. The only drawback I can think of is that we're not going to get the roll, which might be a problem later on. And then I guess that's why Ryan Brooks, he did all the rotation himself around the custom axis, which I also implemented, but I'm not going to be doing that in this video because it's actually giving me something pretty okay still. But anyway, let's do this. So I'm going to take the normal here, and I'm gonna say make rotator from Y and Z. Now the normal was the Y, and the C, the Y is gonna be the turtle's right vector. So this is gonna give us the rotation, and this is going to give us the location. So these two things I want to kind of pack into a macro in a moment. But before I do that, I'm going to drag out the turtle, say set world transform. So make notice that what. Notice I set the world transform. I don't set it in relative space now. I'm gonna split this open, plug in this one, and take my location and plug this one in. So I'm gonna mark this up and collapse this to a macro, and I'm gonna call this macro something else. A and B are actually the same, so they just need to come from here. So, and this is going to be the impact point, and this is going to be the normal hit normal. Okay, how can we do this? Make this a little bit prettier. Okay, and it's going to return to us location, and it's going to return to us a rotation. So I need to give this a name. Get new get surface transform. Okie dokie. So now we can drag this in a little bit closer. And all we need to do now is really to make sure that we update our add segment, which we'll do here. And we still need to take care of the part with the false. So the false part is saying, I mean, if we don't hit anything, we basically just want to move forward. So what I'm going to do here is to, instead of setting the world transform, I don't have any new transform really, so I'm just going to set world location. So I'm going to drag this down here. And the new location is going to be this trace end. The trace end is actually the same point, just carried in and exposed in the hit result really. So it's kind of convenient. Okay, so that was the trace forward part. If I want to have this trace around something, I need to start to keep track on whether or not it's supposed to track around, but right now I don't want to really keep track of that because it's just going to complicate things a little bit. But so it's going to be something I do later on anyway. So let's just for now say that if I don't hit anything, I also want to trace around. Right. So we're going to do another line trace. Line trace by channel. And we can grab some of this stuff up here so we don't have to type in everything. And this time we're going to trace, instead of tracing forward, then we're going to trace down. Or up, I think. We'll see in a moment once we start to test this. So this is going to trace down, yeah. And if we hit something, then the idea behind this is back to the drawing board. Is that if you hit a surface and you continue here, then you would normally just continue that way. But if you come to this point here, then you want to trace down and see if you can find a point, and then you want to set a new point here, and then trace forward and set a point, and basically want to make sure to follow that curve here. And that's going to be done by tracing down towards the surface it was at last time. So I hope that makes sense. Okay, and if we hit something, so the logic is basically completely the same. So do a branch and say if we hit something, we want to break hit result, and then we want to set the world transform to be exactly the same as we did before. So we're going to hook up the impact point and the impact normal and connect up to true. So if we don't hit anything, then we don't want to set the world transform, then we just want to set point. Yeah, because then we just want to set a point, I think, add segment, this part here. So let's drag this out, connect that up, see if we don't hit anything, do a reroute, and connect that one up. Oops. I think this should be working technically. Let me just check real quick. Oh, something is going on. Not exactly as I hoped it would. You can see something is happening. I think I have an idea why this is happening. Now my surface transform here, I get the hit normal. The hit normal is pointing outwards, and in order to get the correct, actually down, forward, down vector, I need to multiply this by a -1. So that means that my hit normal, which is the one going in here, I turn it around. So let's compile that and save. Oh, it's not working. So that's not the only thing that's not working. So the world transform. Let me just check something. Okay, it's debug time, I guess. So let's debug this for duration. What was that? For duration, okay, so we can see it hits here, and then it doesn't hit anything, and then we trace from this point to here. If it hits, set the new. Okay, so I think I'd better set the for duration for this one, which will allow me to see which direction it traces. If I just compile this again. Huh. I wonder what it's doing out here. Huh. I have no idea why it's doing this bend here. I think I need to add this one. Did I make this wrong? Oh, there we go. Okay, so now it's working. Great. I was taking the impact point, adding by the impact point, so it went haywire. Okie dokie. I definitely need to get some sleep. So I'm just gonna wrap this up, I think. So we can see it now wraps itself up pretty nicely around whatever. Works pretty well. Let's finish this off by setting it back to like a tree. Segments per branch. Let me set this down to like 12. And range at every 3. Oh no. What did I do? Oh, 264. Okay, so there we have it. And the whopping tree. Root. It's looking pretty good. Root. If only it would update whenever I move things. That would be pretty awesome, I think. Okay, but anyway, that was the basics of the collision thing I made. I hope you enjoyed, and in the next video I hopefully will have had some sleep and will continue improving a little bit on the collision detection. So stay tuned for more, and be seeing you. Bye bye.